Hello there, this is KP the Math G. Excuse me. We have been discussing derivatives for a little bit now. We're going to get into derivatives of the trigonometric functions. Well, we have sine, cosine, tangent, cotangent, secant, and cosecant. So let's take the derivative, and I'm going to show after we just write these derivatives down, I want to show how to get a couple of these, how to derive a couple of them. So sine and cosine would have to be derived using what we call the squeeze or sandwich theorems. But other than that, the rest of them can be derived from sine and cosine, I believe it is. So let's go ahead and look at it. The derivative of sine is cosine. Then the derivative of cosine is, let's see if I can stand out of the way. Move this over here just a little bit. Hopefully that is negative sine. Okay. The derivative of tangent is secant squared. And the derivative of cotangent is negative cosecant squared. And well, one thing I want you to be aware of on squaring is that you can take, for example, secant squared, and you can put it in parentheses and square it. A lot of times we put the square right there. So just be aware that that is the same thing as this here. Okay. Okay. Alright, let's put that up there. Alright, the derivative of secant, I put this equal sign lower because it is a little longer. It is secant x tangent x. Derivative of cosecant is negative cosecant cotangent. Okay, there it is. And I put in a little star here. Notice something? Notice that every one of these trig functions that begin with C have a negative derivative. The ones that don't begin in C do not. You need to commit these to memory if you haven't already. Again, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. And if you kind of remember, you can kind of keep secant and then just tack on tangent together here, negative cosecant and then cotangent there. Okay, so those are the derivatives. So what I want to do is take a little time now to derive or show that these are indeed derivatives. I'm going to show a couple of these, and let's see if we can do that. Okay. All right. I'm just going to try to keep it all on one side. I know I can flip the board over, but for right now I just want to try to keep it all on one side. Let's do this for right now. Okay. Alright, so let's see here. Let's derive. Let's see, how do we get, let's do the derivative. This also means the derivative of, with respect to x. tangent of x. Of course, if this had been theta right here, then this would be d theta like that. Okay. But we are dealing with x, so we're going to keep it as x. Alright, so there it is. Okay, like that. If you recall, there's an identity to tangent from the pre-calculus days. You would know that that is sine over cosine. And we just did techniques of the derivatives, and we did one with the quotient rule. This is definitely a quotient a over b. So remember, that was the last video that I did. It's low d high minus high d low over low squared. So low would be the denominator, high would be the numerator. So let's see, it would be the derivative is here, low would be up here in the numerator, so cosine x, and then times the derivative of sine. Alright, so we're just going to put the derivative symbol right there. Okay, and remember that the quotient rule always has a minus sign. High, alright, so sine high d low. Alright, I'm just going to extend this. The derivative of cosine over low squared. Well, cosine squared. Okay, like that. Okay, let's see if we can find the derivative of sine. Now remember, we just said, I know I just gone over these very briefly, didn't I? Alright, so the derivative of sine is cosine, that's right, cosine x. Alright, minus sine x, and the derivative of cosine is negative sine x. Okay, and then this is still over cosine squared. Alright, like that. Okay. Cosine times cosine is cosine squared. Okay, like that. And then this is actually a negative sign times a negative sign is a positive sine squared x. Alright, this is over cosine squared x. Okay, there is a property that says, or actually an identity rather, that says that sine squared x plus cosine squared x is some number, right? It's 1. Well, cosine squared x plus sine squared x is the same thing. So we're still looking at the derivative. And I should not do that all the way through. We're doing the derivative as we go. We're not taking the derivative each time. So we should just erase these. I'm sorry. We're not doing the derivative each time of each one of these individually. We're just taking the derivative of this. Okay, now. Okay, that's better. Okay, so now this is equal to 1 over cosine squared. Alright, so 1 over cosine squared happens to be secant squared. And there it is. Okay. So again, the derivative of tangent is secant squared x. Okay. And so that's how you can derive it, but it's better if you can just memorize it, right? Okay. Okay. Alright, so let's go ahead and let's do one more, and I think we'll just stop because my videos have been cutting short. I don't know why. I don't know if YouTube has anything to do with it, or maybe it's my camera. I don't know what it is, but I'm being cut off. And so I'm going to try to make this video a little bit shorter so I can get the whole thing on there. Alright. Alright. Okay. Magic. No, actually magnetic is what it really is. Okay. I want to do one more derivative. This one's a little bit, you got to think about it. Alright, so let's see. We're going to find the derivative of secant. And we already said that it's secant tangent. So let's see. The derivative of secant of x. Now remember, there is an identity to secant. It is 1 over cosine. And once again, we're going to apply the quotient rule of the derivatives. So let's do it. Low d high, okay, and so on, minus high d low over low squared. Here we go. Let's do it. So equals no dx like I did last time. All right, low. Remember, when you make a move, when you're moving this up, you've already made a move with cosine, or with the denominator. So then just get the derivative of the numerator. That means the derivative of. Okay, so minus, that's low d high, minus high d low. So the derivative of cosine all over cosine squared x. Okay, there it is. Okay, so let's see here. The derivative of a constant is 0, so what we have here is cosine x times 0 minus, now the derivative of cosine is negative sine, so minus 1 times negative sine, okay, all over cosine squared. Yes. Good. Alright, we know this is 0, so here we go. This is 0 minus excuse me, 0 minus 1, well actually minus the negative is positive. So what we have here is positive sine x over cosine squared x. Okay. And what we can do here, let's just go ahead and erase the 0. And well, we can do it. And I'm going to do something here. Okay. Cosine x, cosine squared is just cosine x times cosine x, is it not? Okay. So what we can do is, let me move the sign over. Put sign over here, which is still in the numerator. It doesn't matter. I mean, that's a weird way to write it, but there's a purpose behind it. Okay, so up here we have 1 over cosine x times sine x over cosine x, and 1 over cosine. Sometimes you just have to do that, right? I mean, 1 over cosine, this is still sine x over cosine squared x, isn't it? If I multiply 1 times sine, I get sine, and cosine times cosine is cosine squared. So we haven't changed anything by doing this, but we just split it up into 2 separate parts here. 1 over cosine is secant, and sine over cosine is tangent. So if you don't want the parentheses, you can just say secant tangent. There we go. That's it. I'm going to see if I can cut this video a little short. I was going to kind of extend that and show, I think on my next video then I'm going to provide 3 examples where we're applying we're making application to these trigonometric functions is what we're doing. Okay, that's all I have for this study at this time, but I appreciate everyone, and I hope these have been beneficial to you, even in the derivations. Sometimes you need to see how something is derived. Okay, that's just important that you see that. And we could have done all 6 of these, but I believe these will suffice. You could do the same thing for cosecant x. You'll get the same result here, except it won't be secant tangent. It will be negative cosecant cotangent, and you get the same idea is what I'm talking about here. So anyway, again, I hope these have been beneficial to you, and I hope you're learning something from my videos. I don't believe I have a comment section. I'm going to find out why or how I can get a comment section. And so meanwhile, I hope this again helps you very much. Signing off, KP the Math G. Have a nice day, everyone.